All right, guys. By now, you've had a chance to watch the first recording, which kind of introduced the course, went through the syllabus, and hopefully you've had a chance to read chapter one. It's generally a good idea to read prior to listening to the lecture or watching the lecture. Um, but some people like the reverse. I mean, it's up to you if you want to listen to the lecture first and then go and read chapters one and two. But so how this is going to work is so pay attention closely because some people get confused. In this class, we've got the syllabus kind of lays it out for you in terms of the different topics that we're going to be covering and then also the readings. But I want you to understand how the lectures are going to be organized. We're going to have 9 lessons, not 9 lectures, but 9 lessons. Each lesson might take 2, 3, maybe even 4 different, separate lectures. So, for example, lesson one is a bit longer. As you'll see, it's 26 slides, and it'll probably take me, I don't even know, 2 or 3 shots to get through the whole thing. Same thing with lesson two; it's relatively long. Lessons three, four, and five are pretty short. I'll probably be able to get through them in one shot. 35, 40 minutes a piece, and they'll be posted to YouTube, and you'll be able to watch those. Those 5 lessons. The question that you might have is, when should we listen to these? When should we make sure we're done watching these particular lessons? Well, the midterm. If you look in the syllabus, it'll tell you when the midterm is. Make sure that you've listened and watched the first 5 lessons before the midterm. Okay, and then make sure you do all the reading up until the day of the midterm. Right. So basically anything before the midterm, that's what you're gonna be tested on. Okay, and then it's very simple. Lessons 6, 7, 8, and 9 are gonna be done after the midterm. Okay. Excuse me. So hopefully that's clear. So I'm going to start with lesson one now on the nature of the scientific method, really just kind of laying a groundwork for the term. And there's some really important foundational material in this particular lesson and in those first couple of chapters in the textbook. So first, let's think about the different ways in which we can learn about things, the ways of knowing. If you think about it and you just think about yourself, the different ways that you've learned things. You've learned some things through authority, some things through intuition, some things through tradition. So authority is like, your Uncle Bill, really knowledgeable guy, and you say, you know what? I trust what he says about such and such topic. Maybe he's really knowledgeable in politics, for instance, right? Although you have to be careful with that because every uncle thinks he's very knowledgeable in politics, but very few actually are. That's neither here nor there. But so you might rely on your authority figure. If he says it's true, it must be true. That's one way of knowing things, but I think we could agree that that could be dangerous because what if the authority is wrong? Now, sometimes the authority has credentials, and that's good, like your professor. But even with your professor, I always tell my students, don't just assume that everything that I say is 100% accurate. You should always be skeptical, particularly, I mean, in areas of subjective judgment, right? Intuition, that's another way we know things. Sometimes things are just kind of self evident. Tradition, we've always done things this way, and therefore this must be the way to do it. Tenacity, this has always been true, or it's always been good. But we have to ask, is it still good? Is it still true? Things change. So these are different ways that people know. Experience is another way. I remember one time I always give this example. I'm from Minnesota, as I mentioned in the intro, and so we get these really icy roads, right? And the first time I had never heard of black ice before, right? And so I'm driving down the highway, Highway 94. I'm probably like 17 years old at this time, and hadn't been driving for that long. And I did a complete 360, and the roads looked great. Like I thought I didn't think there was ice on the road. I couldn't see anything, but that's black ice. You can't actually see it. It looks, the coast looks pretty clear. Um, that was an experience though that taught me. I was terrified after that. I was very fortunate that there were no cars behind me while I was doing this 360 on Highway 94. I was probably going like 50 or 55. So anyways, but that experience taught me, and now I drive like a granny. They make fun of like old people. Listen, man, old people, they know what's up. That's where it's at, especially in the dangerous weather conditions. Be safe. So experience. That's another way of knowing. So these are 5 different ways of knowing. The book goes through several of these and kind of explains them. But I would argue that the scientific method, excuse me, might be a better way of knowing many things than some of these other methods. The scientific method, I'm not going to say it's foolproof, and I'm not going to say that it answers all questions in life, but it can answer many of our questions. And what's great about the scientific method is that it's systematic. It finds truth through a series of small steps. We go through things systematically. We observe things. We measure things, right? It involves objective analysis. It involves testing, right? We don't just take things for granted. We put things to the test with the scientific method. It considers empirical evidence, right? The word empirical is an important word. This is going to come up throughout the term, so pay attention. The word empiricism refers to observation and measurement. When someone says, I just did an empirical study, that means they observed something and measured it. So, in other words, just to give you an example, maybe somebody says, Fox News or CNN or whatever, they're so biased. Are they? Maybe they are. But a scientist, a social scientist, a media scholar would say we need to observe and measure to find out. We need to observe and measure systematically. So as opposed to just saying, well, I've watched several episodes recently and that's what it appears to me, that's just not good enough from a scientific perspective. A scientist is going to want to take a sample randomly, a scientific sample. You can't just choose episodes, that are going to support your conclusion. You have to choose them randomly. And then the scientist will want to examine them systematically according to some objective criteria, right? That's what a scientist would want to do. And that's an empirical approach. It involves observation and measurement. And the scientific method involves studying things and then restudying things. That's really important. We constantly study and restudy. There's a distinction between the hard sciences and the soft sciences, or the physical sciences and the social sciences. And I want you to understand that difference. By hard science, we just mean the, like chemistry, biology. These are physics. These are physical sciences, hard sciences. We can grapple with stuff. We can touch stuff, feel stuff, right? We're dealing with chemicals and matter and properties, but the social sciences are very different. They're dealing with ideas. So the social sciences are things like sociology, or our field, media studies, journalism and mass communication. We study media systematically, scientifically in our field, right? But it's a social science. We can't grapple with stuff. We can't touch things. It's about measuring ideas, measuring concepts, right? And we have a definition here for social science: the systematic study of what is and why it is that way. Let's look at some characteristics of the scientific method. Scientific research is public. It can be replicated, reproduced, repeated. This is important. You can't publish scientific research. You can't do scientific research and then decide not to publish it, or decide that you're not going to tell anybody about it. Don't expect people to take you seriously at that point. You say, well, I did a study and show it to me. I want to see the study. And when I say I want to see the study, it means I want to read the entire study, including how you came up with what you came up with. That's important. Any scientific paper, pay attention, any scientific paper has a section inside of it that tells you how the researcher came up with what they came up with. It's sometimes called the methodology section. Sometimes it's called method or methods. Sometimes it's called research design. It has different names, but you'll know it when you see it. Basically, the researcher is going to sit there and just tell you exactly what they did. This is how I sampled. This is what I measured. This is how I measured stuff. And the idea is, if you want to come along and do the same study, you can do it. You can replicate my study. And if I've done a good job as a scientist, you should do what? You should basically find the same thing that I found. You should get the same results, right? So that's an important aspect. Scientific research is public. Science, as I've already mentioned, it is objective. Now, is it possible to completely rule out human bias? No. But we can go a long way toward eliminating a lot of biases. And the methods that we use in science increase the odds of us doing so, of us ruling out our personal biases. Content analysis is a really good example. Content analysis is one of the scientific methods that we use in our field, in media studies. And just so you know, there are a handful of methods that we use, that people, scholars, researchers in media use. One of them is content analysis. And it's a very popular method. And as the name suggests, it's a method that enables researchers to examine content, to analyze content. Again, systematically, objectively, right? Empirically, right? We observe and we measure things. So let's just stick to that example that I gave a couple of minutes ago about Fox News and CNN. Somebody might say, it seems to me that CNN is, I'm just making this up, this is just hypothetical. CNN is really supportive of President Obama, and Fox News is really critical of President Obama, right? And you might ask the person, well, why do you think that? And they would say, well, because I flip through the channels and I see it, and it's what it seems to be to me. I watch both networks a lot. As a scientist, I would say that's not good enough. I need to see something empirical. I need to see some evidence of observation and measurement. And so a content analysis would be a great way to do that. What is content analysis? Basically, in content analysis, a researcher would take first of all, they would select whatever they want to analyze. In this case, it's Fox News and CNN. It might be music videos or movies, or you can analyze any kind of content. But in this example, we want to examine Fox News and CNN. So what am I going to do? I'm going to randomly select. It's got to be random. That's how content analysis works. Randomization is really important in science. Okay? Let me back up for a second and explain why. Let's say I wanted to find out what UNA students think about the facilities at UNA. On average, what do the students at UNA think about the facilities at UNA? Let's say I work for the administration. I mean, our university would never do this, but let's say I work for the administration and I kind of want to cheat. What could I do? I could go and just survey the students in, you name a department. I don't even know. I haven't been around campus. I've only been here for a year, and I haven't visited that many of our departments or buildings or halls. But insert whatever department that has really, really good facilities. Like they've got, I know. A good example is the new science building. It's not actually, I don't think it's open yet, but just pretend that it had been open, for a year. So I could go and just survey those students and say, hey, they're UNA students and they love their facility. Sure enough, because they have a brand new building with state-of-the-art facilities, they'd all say, wow, we love our facilities. And I might get something like, 95% of UNA students say they love their facilities. But in that case, what have I done? I've just found what I wanted to find. right? I didn't take a random sample of UNA students. If I want to be honest about it and objective, I have to take a random sample. So I get some science students, some sociology students, some chemistry students, some mass communication students, some anthropology students, some psychology students. It's got to be random. And then I ask them the survey questions about the facilities. And then I can say UNA students believe whatever about the facilities, okay? So content analysis operates the same way based on random sampling. So I'm going to take a random sample of Fox News and CNN episodes, news reports, and I'm going to pay attention to the reports that talk about the president, President Obama, and his policies. And then what am I going to do? In a content analysis scenario, I'm going to have a list of questions. Remember, we want objective criteria. So I'm going to have a list of questions. It might be 5 questions. It might be 10 questions. And I'm going to ask those same 5 or 10 questions of every single news report that I examine. And I'm going to go through, and it's got to be like a multiple choice kind of a scenario usually, right? Like A, B, C, D, or yes, no, something like that, right? So I might ask, does this report quote the president? Yes or no? You might ask, why is that an important question? Well, I think it's important because news networks, news outlets that support someone's perspective usually give that person voice. They'll quote that person, right? That's only one question. We're going to ask a whole bunch of questions. We might ask another question like, was the portrayal of the president's policy positive, negative, or neutral? And we'd have a way of defining positive, negative, or neutral fairly objectively. So we'd go through and we'd examine. We'd ask all those questions of every single Fox News report and every single CNN report, and we'd come up with answers. I think you can, even if that's not totally clear, and it's okay if it's not, we're going to go through, we have a whole lecture on content analysis, and there's a whole chapter in the book on content analysis. That's not my purpose right now. My purpose is to explain that science is objective. And so I think you can agree that that is preferable to just sitting back and saying, well, I've been watching some episodes lately, and it seems like CNN is more supportive of the president than Fox News is. So science is public, science is objective. Science is empirical, as I mentioned. We want to observe, test, and measure. And we deal, to that end, the end of measurement, we deal with operational definitions. What are operational definitions? Remember I said the social sciences, the soft sciences are a little bit tricky because we're measuring concepts. It's easy for me to do, I'm not going to say it's easy, but it's more straightforward to deal with hard science. Because there you've got, I want to demonstrate that water freezes at 32 degrees. It's pretty simple. Get some water, put the temperature to 32 degrees, put the water inside whatever, the refrigerator or whatever, and see what happens. Open the freezer up, and it's frozen. Voila. Try it at 31 degrees. See what happens. Try it at 33 degrees. See what happens. And then you'd be able to determine that it's 32 degrees is the magic number. But in our field, media studies, and in other social sciences, we're not measuring, whether or not something freezes. We're not measuring physical properties. We're measuring ideas and concepts like bias, like support for the president in the example that I just gave, like aggression. A lot of studies in our field want to figure out, do violent video games cause people to become more aggressive? So you have to be able, that's a concept. Aggression is a concept. How do I measure aggression? And that's what we mean by an operational definition. When I ask you, what is your operational definition of aggression? I'm asking you, how do you measure aggression? How are you, in your study, measuring aggression? So an operational definition specifies the procedures that allows a person to experience a concept. Okay? So it's not just defining something in words. It's not saying, well, aggression means this or no. It's actually spelling out the steps that I can take to actually experience this concept. Like I know it when I see it, right? That's what we do. Um, give you one example really quickly, just to stick on that same point of aggression. There are a lot of studies, like I said, that want to figure out if people become more aggressive when they play violent video games or when they watch violent movies or whatever. So what some people do to measure aggression is they put people in real life situations and then they observe their behavior. So they'll make people watch a movie, a violent movie, or play a violent video game or whatever. And then after the movie or after the video game, they put them in real life situations. And there'll be some action, some conflict, something, right? Maybe there are other people around that are actors. And they want to see how the subject, the person that they're studying, responds. And now, how do we measure whether or not that person became more aggressive? Well, they would lay it out for you. If the person hits or punches or pushes or kicks another person, that is aggression. So that's an example. We could measure aggression, or um, that's probably a better operational definition of violence than aggression. But you get the idea. Like we want to specify the procedures, the steps that will allow us to experience and know a concept. So science is empirical. Um, Science is systematic and cumulative. It builds on itself, right? I publish a study, then you read it and you build on it. You publish something else, and then somebody else comes along and reads your study and builds on it. This is why. And if you want to, do this for fun, go to well, I don't know if this is fun, but you could do it anyways. Go to scholar.google.com. Google Scholar, if you go to that site, it'll tell you their little slogan there: stand on the shoulders of giants. And that's our slogan in research. We stand on the shoulders of giants. Other studies, other scholars, we're building. Nothing is original. Nothing is completely original in our field, right? Every study builds on previous studies, which is why, and you'll learn this as we go forward, every study, every scholarly study that you read, any research study that you read will have a section called literature review. Or it might be called something different, but that's what it does, is it reviews literature. What is the literature? Previous studies. The job of the literature review, whatever it's called in a particular study, is to review previous studies. So it's like the first, and it's at the beginning. It's after the introduction. So it's like before you even tell me what you've done or what you found or anything, you tell me what other scholars who have worked in this area, in your research area, broadly speaking, have found. And that's what you do in the literature review. So science builds on itself. Science is also predictive. We have theories that help us predict stuff. That's one of the things that theories do. People have developed theories about the media and violence, and it allows you to predict that if you put a kid in front of a video game for hours every day, a violent video game, that kid will become more aggressive. We have theories that tell us that if you watch TV a lot, that your attitudes, your perceptions of the world will be changed to reflect the TV world, right? Theories help us predict stuff. Think about the science of meteorology. That's a hard science, right? It's not a soft science, but they're studying the weather. They can tell us that. I mean, with pretty good accuracy. It's not perfect, but with pretty good accuracy, they can tell us that it's going to rain tomorrow, or that there's going to be a tornado or something like that, right? So and that's kind of one of the goals of science also, is to predict. Speaking of the goals of science and prediction, there are several goals of science and the scientific method. One of them is prediction, as I mentioned. We want to predict stuff, and part of the reason why we want to predict stuff is so that we can control things. So prediction and control are sort of related in a sense, and explaining and understanding are also kind of related. But we like to predict things so that we can control. Meteorology is a good example. We can predict that there's a tornado tomorrow or whatever that's going to touch down, or in 3 hours or 2 hours or whatever. And then we can control. We can say, everybody take cover so that the damage is lessened. We use science to predict things and then control. A good example is immunizations. If you remember a few years ago with the swine flu, remember that, the swine flu, and everybody was really terrified. What did the scientists go to work doing? They went to work immediately developing a vaccine, and the vaccine was used to what? Control the outcome. And the vaccine ended up saving a lot of lives. It ended up being much lesser. The impact ended up being much less than was originally thought. So one of the goals of science then is also to explain. We see stuff happening all around us. We want to be able to explain it. That's what's happening. And we also want to be able to understand. So we don't just want to explain it, but we want to explain why. And that's kind of, that's why I say they're related. Explanation and understanding are kind of related. So these are four. We could probably come up with other goals, and there are different textbooks that I've worked from that have other goals, but these are four pretty good goals of science and the scientific method. Let's keep on with this theme. What are some characteristics of social science? Remember the distinction between the physical sciences and the social sciences. Well, a lot of repeat information here. Social science seeks objective truth. It's empirically verifiable. It's logical, right? It needs to be logical. It needs to make sense. But here's something interesting. It needs to also be general. Science operates, and social science included, operates on generality. That means we're interested in general patterns. In science, pay attention, we're not necessarily interested only in the exceptions to the rule. We're interested in the rule. So for example, when I was doing my PhD, I had a class where I had some disagreements with some of my classmates, and basically it's a long story, but it was a class on gender, and the argument that was being proposed was that there was no real difference between the genders. And I thought that was kind of, they were saying that gender is a construction, basically. It's socially constructed. And I was like really thrown off by that. I was like, what do you mean? Because there are differences between men and women, like biological. And some of the students in the class, and also the professor in this particular class, sort of rejected a lot of what I was saying. So I tried to make some observations, right? I made one of the first observations that I made was, let's just look at the body types of males and females. Males are, on average, larger than women. They have more body mass, more muscle, and they're taller. On average, right? So if a man and a woman go into the gym and start lifting weights every day and do the same program, the man's going to be able to put on more muscle than the woman. Doesn't mean that men are better than women, obviously. It just means that there are some things that women have that men don't have, and there are some things that men have that women don't have. That's my understanding of things. You might disagree with me. They disagreed with me, obviously, and it's okay if you disagree with me, but that's my perspective on gender, that there's a male and there's a female, and there are some differences, some biological basic differences. And this is just one example, body type, but I went through a whole bunch of stuff, and they kept on throwing it back at me. And I think it was a misunderstanding about generality. And so when I said, for instance, that men, on average, are taller than women, one of the students in the class said to me in response, she said, but I'm taller than you. And she is. She's taller than me. I'm 5'10". She's like, I don't even know. She's probably like 6 foot. She's tall. And I said to myself, she doesn't understand what I mean. I mean on average. Science is concerned with the general pattern. It's not concerned with the exception. Of course, there are some women who are taller than some men, But on average, if you take a random sample of men, 1,000 men and 1,000 women at random, and you measure their heights, the men are going to be taller. That's just the way it is in any society. I think in the United States, I think the average height for a man is 5'10". If I remember correctly, I actually looked it up at the time, and I think the average height for a woman, don't quote me on these, I might be off a little bit, is like 5'4". Something like that. So it's several inches. I mean, it's not like it's a 1 inch difference. And the same thing if you look at weight, body weight. Men tend to be larger. And I tried to explain this, it just didn't go over very well. So the point is, we're talking about general rules. We're not talking about every exception. That's why when people say, when the research shows that, for instance, playing violent video games excessively tends to affect people negatively, like it makes them more aggressive and so on and so forth, it alters their perceptions of reality and so on and so forth, it desensitizes them to violence. We don't mean that happens, scientists don't mean that happens for every single person. It just means that if you take 1,000 people and have them play this video game, it's going to happen with a lot of those people, right? That's what is meant by that. What else? Science is skeptical. What do we mean by that? The scientific method in science, you always want to kind of have some doubt. You want to be skeptical. You don't want to take things at face value. And that's why scientists want to measure stuff. That's why it's related to empiricism. They might say, well, this news network is biased. Well, maybe, but I'd like to measure it. I'd like to actually empirically verify this. Okay? So these are characteristics of social science. And I just want to note that science can't answer all kinds of questions, right? Science is good for some things. It might not be so good for other things. This is the example that's given by one of the authors of one of the textbooks. Should media do something more than merely distribute whatever content will earn them the greatest profits in the shortest time? That's an ethical question. It's not a science question. I'm going to stop here, and we'll pick this up at the next slide on theory in part 2 of this lecture.